Hi class. Today I'd like to take a look at some rational functions. Alright, so rational functions meaning, we have a ratio, or in other words, there's some division. Okay? These can be kind of tricky, so I'm actually going to go over two examples. The first one is example 6 on page 242. The book works it out for you, but I don't think they do it in enough detail, and there's a few things I want to talk about. So we'll go over that one, and then we'll do another example problem from the homework set. Okay, so first things first, when we have rational functions, a lot of times we'll have asymptotes. Okay, and to find these asymptotes, factoring is a great first step. Alright, so let's take a look at this problem right here, and let's try to factor. Alright, I think we're all pretty good at factoring, so on top I'm going to take out a greatest common factor of 2, and on bottom I'm noticing two perfect squares with subtraction, so difference of squares, so that'll be x minus 2, x plus 2, and notice that pops up again on top. So I'm just going to finish factoring here. Alright, now that we are in factored form, a lot of interesting information falls out of this. Okay, so for example, what happens when the numerator is 0? 0 divided by anything is always 0, right? So anytime the numerator is 0, f of x is 0. Or in other words, the y-coordinate is 0. So that'll be our x-intercept. Alright, so for example, when x is 1, 1 minus 1 is 0. So when x is 1, we have a 0. And same story here. How about when x is negative 1? Negative 1 plus 1 is 0. 0 times anything is 0 times anything is 0. So the numerator is 0. And anything divided by 0 is 0. Alright, so once again, there's another 0. Okay, so what I'm getting at here is anything that makes the numerator 0, you can plot as zeros on the graph. How about what makes the denominator 0? What happens there? What's something divided by 0? Well, that's undefined, right? So those are asymptotes. Alright, so there will almost always be asymptotes. Whatever makes the denominator 0, in this case, x equals 2, and that's the equation of this line. Please note that this is not just the line 2, this is the line x equals 2. Alright, and then we also have another asymptote at x equals negative 2. So I'm going to graph that up. Alright, so those are our two asymptotes. I said that they are 99% of the time going to be asymptotes when the denominator is 0, but every once in a while they will not be asymptotes. Alright, when that would happen is if, let's imagine this was x minus 1. If this was x minus 1, and there's also an x minus 1 on top, those would cancel out, and we would not have asymptotes. Instead, we would have a whole. We'll talk about that later, though, when that happens, but if there is the same factor on top as there is on bottom, we will not have an asymptote. Instead, we will have a whole. But we'll talk about that later, like I said. So let me switch that back. Okay, so things are looking really good. We got 2 points on our graph. We have asymptotes, and let's see what else we can get. How about horizontal asymptotes? A lot of times rational functions will have horizontal asymptotes too. Alright, so remember, when we want to figure out the horizontal asymptotes, we need to look at the degree of the numerator, 2, and the degree of the denominator, 2. Alright, when there's a tie, what happens? We look at the lead coefficients, 2 and 1. Alright, so that's going to tell us that y equals 2 is going to be a horizontal asymptote. Alright, so we've got all our asymptotes, we've got 2 points. It still seems tough to figure out what this graph is going to look like, doesn't it? So let's remember that anytime we want to find a point on a graph, all we have to do is plug in an x value. Alright, so for example, I'm going to plug in an x value of 0, and let's see what happens. 0 squared, 0. 2 times 0, 0. 0 minus 2, negative 2. So on top we have negative 2. 0 squared, 0. 0 minus 4, negative 4. So we have negative 2 over negative 4, which is positive 1/2. So when x equals 0, we got out a value of positive 1/2. So I plotted that up. Okay, and I'm going to make a guess, and it's going to be a pretty good guess, that this graph in between the two vertical asymptotes will look like that. And I think it'll be a pretty good guess, but if we wanted to check that, we could easily do that. We could take a value like 1.5, and plug it in all these places, plug in 1.5 and see what we get. Let's just do a quick check. So we're expecting when we plug in 1.5 to get a negative number. Let's check it out. So let's plug it in. 1.5 minus 1, that'll give us a positive. 1.5 plus 1, that'll give us a positive. 1.5 minus 2, a negative. And 1.5 plus 2, is a positive. All right, so here we have only factors and we have an odd number of negatives, so we should get a negative, so that checks out. All right, so that part looks pretty good. We can talk more about that in class, though. Now let's figure out what's happening in this part of our graph and this part. Is x allowed to be 3? Is x allowed to be 4? Is x allowed to be negative 3? Is x allowed to be negative 4? I think so, but let's check it out. Let's see what happens. So let's plug in 3. So let's plug in x equals 3. I'll do this work down here. So f of 3, and I'm going to plug it in right here. So we have a 2, and then 3 minus 1 is 2. 3 plus 1 is 4. 3 minus 2 is 1. And 3 plus 2 is 5. So on top we're going to have 4 times 4, which is 16, and on bottom we'll have 5. Alright, so 16 divided by 5, well that's a little bit more than 3, right? As a matter of fact, it'll be 3.2. So f of 3, so when x equals 3, our y value is 3.2. So right there. And then I could do the same thing for f of negative 3, but I'm going to get the same thing, which is 3.2. And we can talk more about this in class, but it's because we have an even function, right? An even function is where it doesn't matter if we're talking about f of positive x or f of negative x, they're going to be equal. In this case, that's happening because our x is being squared on both the top and the bottom, and so it doesn't matter if it's positive or negative. So when I plug in 3 for x into f of x, I get positive 3.2, and when I plug in negative 3 in f of x, I still get positive 3.2. But if you'd like to go through that work, you can, but we will get the same thing. So I'm going to plot in that point right there. So remember, this is called an even function because it's symmetrical about the y-axis, because it doesn't matter if x is positive or negative, we get the same y values. All right, so I'm going to make an estimate here. We have these asymptotes. So we approach the asymptotes at infinity, we go through our point, and then we approach our asymptote at infinity, remembering my arrows. Approach the asymptote at infinity, go through my point, or try to, and then approach the asymptote at infinity. All right, so this is my guess of what this graph will look like. I got several points by hand, and I got my asymptotes by hand. And then from there, I'm making some estimates of what I think the graph will look like. You can always check it on your calculator, so let's do that. Looks pretty good, right? Remember our zeros were negative 1 and 1. We went through 1/2. We went through 3, 3.2, negative 3, 3.2. Negative 2 was an asymptote. X equals 2 was an asymptote. And y equals 2 was an asymptote. All right, so things are looking pretty good. So there's the first example I wanted to go over. Here's the second example. This one's going to be a little bit different. So we're doing problem number 52 on page 246. Okay, this one's a pretty tough one, but let's try where we were before. All right, let's factor. So the top, I'm noticing both terms have a 2x in it. So I'm going to factor that out, the greatest common factor. When I take a 2x out here, I'll have a 2x. When I take a 2x out here, I'll have a 1. Please don't forget, this is a 1 here. 2x times 1 gives us 2x, not 0. A lot of times people just leave this out. Be careful. All right, now let's try to factor the bottom. So we're looking for things that multiply to give us 8. 8 and 1, and 4 and 2. Do any of those added up or subtracted give us 4? No. All right, so this one's going to be non-factorable. All right, so what that means is we want to go to the quadratic formula. All right, so remember, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Let's look ahead really quick. So let's cheat. Let's go to our calculator. Wow, this is interesting, right? No vertical asymptotes. All right, the reason there's no vertical asymptotes is because this denominator is never going to be 0. All right, it's never going to be 0. All right, and if you think about this mathematically, the reason that is because this quadratic formula tells us the x values where this is 0. But it's never going to be 0 because this number right here is always going to be negative. All right, we call that the discriminant. I know you've talked about this before, but I wanted to review. That's called the discriminant. And let's check it out here. So b is negative 4. Negative 4 squared is 16 minus 4 times a, which is 1, times c, which is 8. All right, so we have 16 minus 32 equals negative 16. All right, so the discriminant is negative, which means this denominator right here will never equal 0. All right, so it's not factorable, and it never equals 0. All right, so that is why in this graph there are no vertical asymptotes. All right, but there is a horizontal asymptote. All right, much like the same thing before, our degree ties, so we look at the lead coefficients, 4 over 1. So we do have a horizontal asymptote of y equals 4. And we can also get those zeros. Those zeros are going to happen when x equals 0 and when 2x plus 1 equals 0, and that'll be x equals negative 1/2. So those are the zeros. But there's 2 more points here I wanted to get. Now, this one would be tough to graph without a calculator, and I wouldn't really expect you to. If you really needed to get more points without a calculator, just start picking out some x values and plug them in and see what you get and plot those points. All right, but in this case, it's okay to use your calculator. And let's look at our calculator, and this is the graph we get. So we are approaching a y value of 4 at positive infinity and at negative infinity. But one thing I wanted to point out here. A lot of times we think, oh, we can never cross the asymptote. And we say that a lot. Oh, you never cross the asymptote. You only approach the asymptote. But that's at infinity. All right, so as we get way out to the right, this graph is going to come down close to the asymptote. And as we go way to the left, we're going to come close to the asymptote but never touch it. But notice here, it crosses the asymptote. Please do not let that bother you. That is totally mathematically correct. You are allowed to cross the asymptote. That happens sometimes, at least for horizontal asymptotes. You can cross horizontal asymptotes. That's okay. It just gets approached at infinity and at negative infinity. It's okay to cross it in the middle. All right, guys, so that's all I wanted to talk about right now. If you have any questions, please write them down. I hope you have questions, and bring those to class tomorrow.